Slides now?
Yes.
Okay, perfect.
Yes, sir.
All right, good. So I think we should start. So Helen, maybe we can start recording. All right, so let's officially start. Hello, everyone. Welcome to the next meetup organized jointly by quantum computing groups from Washington, D.C., Toronto, and Warsaw. My name is Paweł, and I'll be one of the moderators. The other moderator is Sebastian Zając, who's also from Q Poland. And today we have pleasure to host a great speaker, Martin Musiol, who is the founder and CEO of Generative AI. And he will give a talk titled Generative AI and Beyond. So actually, as you will see, this is our another lecture dedicated to AI and not necessarily to quantum computing, but maybe later there will be some questions on how quantum computing could help with this approach, or maybe vice versa. Maybe we'll learn how generative AI could be applied to develop better quantum technologies. Before we start, just a few announcements. So first of all, as you can see, this lecture is recorded and there's also live streaming on YouTube, and the video will be later available on the same link. So Helen will later share the link if you're interested. And we've also agreed with Martin that if you have some urgent questions related to the slides, you can we can interrupt. So please raise your hand, and then we'll try to interrupt and ask these urgent questions. If there are some more general questions, please post them on our chat, and at the end there will be a Q&A session, so when we'll have time to ask the questions. And I would also like to announce some of our next events. So in about 2 weeks from now, Zeki Seski will give a talk about educating to the culture of quantum technologies, a survey study on concepts for public awareness. Then in August, I will be the speaker, and I will tell about optimizing complex processes using AI and quantum computing. And then in August, Sasha Yoshi will give a talk about Picture, a quantum machine learning library for image processing. And later in September, Professor Rafael Sotelo, who has already been a speaker with us, will give another talk, this time about quantum computing and finance. Then Eric Reiter will give a talk about the critical history of quantum mechanics. And finally, we'd like to thank our partners and sponsors for helping us in organizing this great event. So we hope you will enjoy. And now I will stop sharing my slides. And Martin, first of all, thank you for accepting our invitation. It's our pleasure to have you with us. And if you are ready, the Zoom is yours. And you can start sharing your slides, and we are looking forward to your presentation.
Perfect. Thank you so much. Thank you for the warm introduction. And I must say, I saw the upcoming presentations, and it looks very, very interesting. I might join for sure. Okay, then I will share the screen. Okay. And you should see now slides. Could you quickly confirm?
Yes, I can see your slides.
All right. So this here I would like to draw attention on generative AI, even though there is a lot of attention already on generative AI. Yeah. However, I would like to expand that spotlight to AI agents as well as artificial general intelligence. So where all of this is going. Maybe you are already convinced that generative AI is here to stay. Maybe not. I can say I started very early in this space. The first time I talked about about generative AI was in 2016. In fact, in Italy, in Milan, on a data-driven innovation conference, and I can share about that in a moment. But 2018, I founded GenerativeAI.net, so roughly 4.5 years before ChatGPT has been released. And I always could monitor the analytics of the web page. And I saw for years and years, I saw roughly 1,000 visitors a month, yeah, GenerativeAI.net. And then in summer 22, DALL-E came out, the image, quite higher quality image generation, and I saw like a quite a peak. I was very excited about that. And then with ChatGPT, December 22 or end of November, beginning December 2022, it really took off. And since then, there are news over news and new products, new ideas. And I would like to, look a bit closer to all of this and where all of this might go. This you see, it's an exponential curve, and this speaks to a lot of things in this field. We see an exponential growth in computing power. We see an exponential decline in costs for data storage. Yeah, so more can be stored. An exponential increase in investments in the space. An exponential increase in talent in the space following the investments. Yeah, startups, products. We have lots of very exponential like behaviors that are also converging, tech convergences with the computing power, which all of it drives the wave of generative AI. Some say it's hype. There is for sure some hype degree in it, but there is also real value that I would like to show you in this presentation. Today, we discussed that we would like to talk about some fundamentals, of GenAI and where all of this is coming from, and also the progression perhaps from traditional AI or conventional AI. I would like to look at what tools and platforms exist, use cases and applications, some technical principles, AI governance, regulatory frameworks. I would like to put this in brackets because I think this is super interesting and important to know and to look closer at it. But I think there are so many more topics that are perhaps in the first presentation are more exciting. So I would like to put this in the backlog in case we want to discuss it later. Societal and ethical implications, and then my favorite part of that is the looking forward, AI agents, AGI. And where all of this is sort of going. I am Martin Musiol. I'm in AI since now roughly 13 years, but starting, of course, with conventional AI. I talked about, I said already, 2016, I talked about generative AI. And the reason why I spoke about it, and to my knowledge, that's sort of like one of the first presentations on this topic. I stumbled upon a paper in 2014 that was called Generative Adversarial Networks by Ian Goodfellow. And so he's proposing in this paper that two AIs, two neural networks are competing against each other. And while the one is generating things, the other one is discriminating, generating data. The other one is discriminating if that generated data is real or fake. And along that adversarial, they are getting better and better in detecting as well as in generating. And with that mechanics, lots of things could be done. Yeah, and so I was very fascinated by this. Then early pictures came out, very highly pixelated, and not really clear boundaries of certain objects. But I could see, okay, this goes somewhere, and looking forward 10 years, 20 years, we might have indistinguishable pictures from humans, for instance. And this happened all much faster. But I was talking about that and how this can improve the products we build and services. I was in consulting at that time. I founded 2017, 2018. I founded Generative.net and launched, to my knowledge, the world's first online course on that topic. And I also wrote a book. It's called Generative AI, together with Wiley, the publisher, navigating the course to the AGI future. Up until recently, I was the Generative AI Lead for Europe, EMEA basically, for Infosys. And there, my main job was leading teams in developing professional applications in generative AI. So it's not all POCs, it's also real world applications, real value being delivered. I'm happy to talk about that. And feel free to also ask in case you would like to. And also maybe one thing I would like to draw attention before we continue. You see the Pong game, I will talk about that later. I have also a newsletter where I discuss every Tuesday some deeper topics. Yeah, so AI upgrade, customer service, or for instance, Llama agents, or small language models. It's not all about large language models, also about small language models and why they are better in 90% of the cases. And every Friday, I'm wrapping up the week with the highlights of the week. All right. Where's the presentation? Here. First, I would like to take a look at what exists out there for GenAI. But before we do that, let's see what is the difference between conventional and generative AI. Conventional AI is the AI basically before. Wait a second. Okay. So in the conventional AI, that still drives lots of applications, business professional applications, or can be put into these types of the conventional AI, like classification, a classification, like for instance, unlocking something with our face, or do we have access to the phone or not? Is an email that comes in spam or not? Regression, for instance, like it is used in weather forecasting, clustering. So basically speaking to recommendation engines, is you are being clustered into a certain group of people that might like a new content, a new movie that comes out, or a certain song that comes out. And this is, of course, also being exploited or lots of business value for companies like Meta or Google, where they drive you the ads that are that are potentially interesting to you. Recently, I was speaking at home here that we would like to go to Japan. And literally 12 and a half hours later, I got this ad from Instagram. Win 2 tickets to Japan. So that definitely works. I think it's like 250 million, or no, 250. I don't know any figures, but insane figures regarding Google, the Google business. Dimensionality reduction. This is a bit more scientific, but basically which dimensions or which type of the data are carrying information. And then applications like reinforcement learning. So a warehouse robot, which path should it take, or an assembly line, which element should be taken first, or along these lines. This is all from conventional AI. And if you think about all of these types that I described, it's basically about discriminating. Is it my face or not? Is it can I recommend this content or not? Do we take this data? Does that data carry most information or not? And it's basically about deciding, selecting, discriminating as the technical overarching term. And that's why this is also called discriminative AI. In contrast to discriminative AI, which if you take as an analogy, this is roughly 10 years before. So here we have the success roughly, 8 years before generative AI. And why is so? So generative AI is generating data, while discriminative AI is discriminating on data. And if you think about it as an analogy, it is easier to judge or to make a decision based on options or just making a decision in general. It's easier than building something yourself. And I think this makes also sense in the technical space. Generative AI came 8 years later and has mainly 3 main tasks. The first task is quite obvious. It generates all kinds of data. It can be sequential data, like speech, music, sound, time series, code, text, of course. But then also parallel data, such as images, or 3D objects, or a hybrid of it, such as videos. You have parallel images being generated in parallel, but in a sequence, and you need this coherence throughout these different frames, which is video, and we see also video being generated. The second task that is quite that is one of the main tasks is domain transfer. Or maybe before I talk about this, This is, I think, a good analogy to generating things. You see in the roots of that tree all different types of data going in. Yeah, speech, video, image, code. It's in a nutritious ground. So I was talking to the talents, I was talking to the funding, I was talking to the value from basically minute one from ChatGPT, for instance. Yeah, lots of records in the signups and so forth. So there is a reason for that. And then the tree of GenAI basically extends into many different branches, and these are representing sort of the applications of it. So the second task is performing a data transformation, such as a domain transfer or a style transfer. Here you see an example of a domain transfer which is very real for autonomous driving. You might have some real images, so winter images, but you want to expand the data set to many more scenarios. You want to cover basically virtually all scenarios possible when you let the car drive multiple people. And you can transform winter images into summer images, or a sunny image into a rainy image. And yeah, this is one application. Style transfer is when you have many different styles that you would like to apply. Also possible for data synthesis. And the third task is improving data sets. I have one example later as well, where you have maybe a restricted original data set, and you can inflate that data set with some synthetic data and improve ultimately the machine learning algorithm, detection algorithm that is at the end. Yeah. Pablo, I see that there are two, I don't have the chat open, but are there any questions?
So there's one more general question that we can just leave for the Q&A. There's a question about your thoughts on the work of Ray Kurzweil and Jeffrey Hinton, but we can discuss it at the end.
Love it, yeah.
Can I ask something there? Just before you go, you talk about this convention against generative, but I was looking something about making decisions. Is that part of convention or generative regarding decisions? If AI could make a decision based on data or on a set of criteria, make decisions regarding safety or economics, for instance.
Yeah. So that's a good point. So technically speaking, this could be a discriminative AI or conventional AI part, where you have maybe some algorithms that are extracting certain information, and then you have a classifier that decides something, whatever the use case is. But the beauty actually with generative AI is also it can generate the decisions. So it can generate with a chat. If you open ChatGPT and you explain it, you give it proper context. And later I'm talking also about prompt engineering, how this works good. You can give it some context information, and you can ask it to, hey, let's say here's a report. Can you please, based on that report, tell me, should I do X or Y? And then it can give you a reasoned answer why it would do X, for instance. So you have also decision happening there. So yeah, but technically these are two different, on the technical level, these are two different approaches. And maybe one is better than the other. It's hard to say.
Yes, man, thank you.
Okay. So yeah, I already mentioned it. Yeah, ChatGPT, or here that's Gemini. Text generation is one application of it, like the most dominant one, but it's not the only one. We have also image generation, and image generation became, so when I first looked at it, it was really low quality in comparison. Here are basically no limits. You can even tell the image generation model to generate text, and it's not like it's easy for the model, because it has to arrange the pixels. It has to learn through the data set how to arrange the pixels so that the pixels actually represent a text, and then the text makes also sense. Yeah, so they were struggling quite a lot with that, I think, obviously, and there were many typos, but and many weird signs that they were not correct. But the models are getting so good that they are able to do that. You can create humans, yeah, that are indistinguishable from real humans. There are no artifacts in the backgrounds or anything anymore. Yeah, all kinds of maps. The second thing, or the third thing I would like to talk about is AI avatar generation, yeah, or and also later to movie generation even. But the the ITU, it's a subsidiary or like some sub-organization of the UN. Is hosting this AI for Good conference, and in the AI for Good, I'm not sure if it was this year, but definitely already last year, they had even an AI avatar moderator for a sub path. Yeah, so they are taking over also on that end.
Welcome to the Generative AI presentation. Generative AI is the future. Let's dive into it.
Could you actually hear this right now, or do I need to?
Yes, yes, we are able to
You could
hear.
hear, yeah. So yeah, here I basically just gave it some script, whatever I wanted to say, and it says it, and it also moves the hands accordingly to the text, yeah, and the facial expression is guided by the text. And Hey Jane is I didn't take the pro version here, yeah. This I can choose whatever avatar I want and then let it speak, and I can also train a voice. So this is yeah, one thing that I would like to draw attention to. Then what I would definitely like to draw attention to is we have models like Sora, Kling from China. We have Runway ML with their Gen 3, and also Luma AI with their Dream Machine to generate videos. Yeah, so frames of images arranged in a way that they are representing a good video. Yeah, so there's a proper coherence. And I would like to show that there are now on X, at least in my X feed, it's flooded with videos, so I couldn't even properly choose one, but I just chose this one to show you. Let me see. Okay, I'm not sure how well the quality was now on your screen. For me, it was it's yeah, it's a good.
It was
Yeah,
quite good.
was good. Yeah, and so the sound is so the video is generated by prompt, by just some prompting, yeah, prompting some story. The sound, I think 11 Labs has been used for that. So what 11 Labs can do is you take the video, you give it to the 11 Labs model, and it will create the respective sound to it. So you need basically two videos to create a really high quality video. And of course, this is the weakest AI that we have, yeah, here. This is basically true for the whole presentation. I'm showing here the weakest the weakest AI in the future that we will have. It's only getting better from here on. Yeah, and we see already ads. Under Armour has already an ad for this, and Coca-Cola has done an ad with GenAI video generation. Next, I would like to show 3D object generation. This will be especially useful for virtual reality or games. Let me show you this clip. It's a longer clip, yeah. But on the left-hand side, you see that someone is typing in what that person wants to see. Yeah, starts with chapter 2, a completely new plane, and then yeah, what does it say? The recently built road abruptly came to a halt, only furthering slightly in two opposite directions. near the end of left branch stood a detached garage. Yeah, and so forth. Yeah, I stopped the clip here. But basically that person is building a whole city and then can walk through it. This is, by the way, happening with Opus AI. Yeah, then next I would like to show data augmentation. This is what NVIDIA already has done early on. We have, this is basically the third task that I was mentioning earlier. We have a restricted original data set. So in this case, it is a rare cancer. And with rare cancer or medical images, we also have the problem with data privacy. Yeah, so we cannot use all of the data to train a detection algorithm. So based on that, a detection algorithm has been trained to detect cancer instances. I think, benign cancer instances. And it was at 64%. And what they have done at NVIDIA is they have increased the data set, they synthesized the data, mirrored the tumor and then blended it in, or increased the tumor by 16%, blended it in, smaller 16%, blended it in, and so forth. And based on that new increased data set, they were retraining the detection algorithms, and it jumped from 64% detection accuracy to 82%. And of course, much more is possible in the future. I'm very positive. There are even full applications where the use cases, they are only trained on completely 100% on synthetic data. One example of this is the Google DeepMind alpha geometry. I'm not having an image here right now, but alpha geometry, you can maybe Google that. It is an AI system that solves Olympiad geometry problems at a level of a human gold medalist. And to become a human gold medalist in geometry, there's roughly 50 people in the world that are having that status. You really have to put a lot of work, effort, discipline into it in order to get to these levels, and you might not even make it. So this is solely trained on synthetic data, yeah, and it can solve geometry problems on such a high level. Yeah, and generative AI is also being used in many more fields in science. Yeah, it is being used for finding vaccines, and in Silicon AI is doing this, for instance. And that's a whole rabbit hole right there. You see, there are not hundreds but thousands of different applications. By the way, top bottom, you see there's under education and courses, you might find generative AI, the green one. This is mine. But there are many different. And this is, by the way, from dealroom.co. If you want, I can also share the link, and you can explore all of these apps. Okay, I think it's a good idea to dive a little bit deeper on the technical end, and then we speak more high level. So with the technical, a bit more deeper dive, I would like to talk about how sequential data is actually being generated. So what is the GPT and ChatGPT? GPT stands for Generative Pre-trained Transformer, and it was presented already 2017 by Google in the paper called "Attention is All You Need." And with that paper, I think right after that, but based on that paper, they have then introduced or open sourced the model BERT, which is the first transformer, in the space. That 2017 we are speaking, and now think of it like, what if they would have taken their BERT model, have maybe increased it in size, because it was 94 million parameters, but increased it more in size, and then trained it a bit more and put it into like a ChatGPT sort of like framework. They could have been much earlier there than OpenAI, presumably. But they haven't seen the value as much as OpenAI has seen. And that's why, they are now basically running slightly behind. They have caught up well, but initially they were running behind. And so what is this attention, basically, this attention mechanism that has been proposed in this paper? And I think that what explains it well is, so before Transformer, we had LSTMs that were most dominant in this space. And this is the blue dotted line here on the top right. And if it has consumed, let's say, a book of 300 pages, it does not, so consumed, scanned basically through. It has not, so you see this, it's 100% on the x-axis, and it probably only like 7% are very dominant in the space, in that model, in terms of the knowledge. So the last 7% are in the know for that model. And when you ask, if you would put in a chat sort of a framework, and you would ask it questions that are earlier than the last 7%, it would have not been properly able to answer that. And a transformer is capable of having the attention basically across the whole document. So if you have a book of 300 pages, it would know what is on page 5, what is on page, what is relevant on, to answer a question on page 74, 96, 128, 397, but can recall these relevant information much more reliable by architecture. And the beauty also with these sequential models is that you can very simply train them. You take a long text, for instance, the Wikipedia, you download Wikipedia, all of its corpus, easily done. And you go word by word. So the model in training takes the input. Let's say we start, and then there is a chapter that starts, the impact of GenAI is, and then the model in training takes it and predicts bad, for instance. And then in the training, it's then being labeled as no, that's not correct, because we know what the next word is. The next word might be good, because we have the text, it predicts the next word. The next word is not correct. It says, hey, this good is the next word. Good is being taken as the correct word, and for that's being used for retraining or calculating the error, which then is needed for updating the weights in the model. The weights are, with weights, I mean trainable parameters in the model. So values, basically, but not hundreds, not thousands, it's literally millions and billions of these values. We have a chart, I think, soon of the sizes. And this is basically how these models train. And you can go through all of the different lengths of text, and the model gets better and better. For a model to be good, there are many different aspects, but the amount of data, training data, and the model size are the two most important ones, I'd say, or the first one coming to mind. If we see, so Elmo on the left is a model that is not on a transformer model basis, but it's a LSTM with 94 million trainable parameters. BERT has 340 million trainable parameters, starting basically the era of transformer architectures. And you see, and it's a logarithmic chart, so it has an exponential increase. And GPT-3, so which was taken as the ChatGPT release version, has 175 billion trainable parameters. And I think we still don't know it fully, but GPT-4 was expected to have 100 trillion, which is probably not true, but something in between. But we see we saw an increase in the model size. However, that's not fully true, because there is also another trend, and that is the smaller models, the small language models, or the mixture of models that also provide extreme high value or high quality. I would like to reference here my newsletter, where I'm writing about why small language models are in 90% of the cases better. But we see definitely this trend, that smaller models being on a good level, and then also the trend of large language models still increasing. And in the future, as well as now already, we will have both. Okay. And just to the bottom part, yeah, so initially it was very, it could provide value more on an infant level or toddler level. You could not even speak in the beginning with these language models. And now we are going to adolescent and even to junior professionals. And actually, I think we're already at senior professionals in certain areas. I'm showing this later. I'm showing how I coded something with AI hands-on, yeah. How much time do we have left, Pablo? And also, I think there are questions.
Yeah, so regarding time, so you can take still about 1 hour, so no worries.
Okay,
And regarding questions, yeah, so there is another more general question that we can ask at the end, but let's see, maybe some participants would like to raise a hand and ask more detailed question related to the slides now. If not, then I think we can proceed.
Okay, then I would just very super briefly would like to touch upon how parallel data is being generated, and then that's it with like deep technical. But we can then dive deeper into tech if wanted later. So just for that, it's if it's not clear how parallel data is being generated, with parallel data being an image, for instance. So we have this cat sitting on a desk. So the main algorithm for doing that is called stable diffusion, which, by the way, has been developed by the LMU University in Munich, and Stability AI, and then open sourced by Stability AI, I think in 21 or 22, 23. I'm not fully sure on this. So how this works is that you have an image and there is noise being introduced, gradually up until it's very noisy and not understandable what image it is. And then models are being trained to stepwise denoise it. So getting only this last step, understanding how to adjust the picture so we are back at the step before. This is being repeated for each diffusion step, yeah. And in the process, we clip the text, the description of the image. So the description for this image could be, cat on sitting on a desk, minding its own business, for instance. And this text is in each step being clipped, and clip the algorithm is literally called clip. Is clipped to the text. So we have the image to text clip, and at the end, what you then get, again, super high level, what you get is you can prompt, you can say, write some kind of text, and it generates then a respective image. Okay. This was now a little bit to the technical side of things, sort of like the ground functionalities. And from these ground functionalities and mechanics, how can companies capitalize on AI advancements? As up until last year, I have been the GenAI lead, so I spoke really to lots of different clients on a weekly basis. It was actually a very interesting position because the clients were reaching out to us. Why did they reach out to us? Because they had many ideas coming up. Why so many ideas? Because it's really from bottom up. The employees, it's at their fingertips. They can try out things. They are working in their respective field. They see, hey, if AI can do this, then we can actually build like a tool that could do this because it's apparently technically possible. And that's why sometimes we had clients that came with lists of ideas and use cases to us, and and we were then filtering with them this out and started a couple of engagements, and even up to a full AI transformation of corporations. Super interesting times, I think. And now, so last year was the year of the POCs. This year is the year of the MVPs and also in production solutions. Yeah. because to be very honest, the amount of investments and the actual value and the capitalization of this, there is a huge mismatch. But of course, it takes some time to really, develop the tools and make them, create value for customers. So roughly a year ago already, McKinsey has published this survey where they have mapped the business functions on the top. Yeah, you see marketing and sales, customer operations, product and R&D, software engineering, and so forth, risk and legal. And they have mapped this against the different sectors. I truncated this list, at some point. So it's actually really a very exhaustive list. But what you can see here is marketing and sales, by the way, is across the board a topic that where AI can be leveraged, often with tools, different tools like Jasper or image generation and campaign generation and so forth. So this is not so much sector related. But also in banking, you see it a lot. Yeah, I have maybe I didn't mention this, but I also have a consultancy myself now. And we implement with clients different solutions, and in customer service we see this as well. That they want to, so as emails come in, they want to automatically pre-draft emails or extract certain information from various documents. I can talk a bit more in detail, but I think this is a very valuable survey in case you would like to dive deeper. You see also per sector how much potential there is. In education there's a lot, in healthcare there's a lot, in banking we had a transportation client, I have an energy provider client. Like it's really across the board, and there is potential value for everyone. On the CES this year, Volkswagen has announced that they are also using ChatGPT. Let me show you this ad in case you haven't seen it.
Hello, Ida. Do you think a kilt is formal enough for a red carpet event?
According to ChatGPT, people regard kilts as elevated dress suitable for formal affairs.
Fantastic. Find me the nearest kilt shop.
Okay.
And Ida, play Scottish playlist.
I'm playing Scottish playlist.
Yes.
The VW ID7 with ChatGPT.
So yeah, when even a relatively conservative car manufacturer from Germany, and in Germany we're also a bit more like tech reserved, I would say. If they are even doing the commitment to implementing ChatGPT into their cars, then I think it's like one of the strongest signals for me, at least, that it's the way to go. That was in the beginning of the year. And let me now tell you a couple of anecdotes of how we implemented, or what we implemented for some clients, my teams and I. So I already mentioned we had an international container shipping company client. And what their business is they take containers and they ship it from one country to another for their clients. And so there are many regulations, and typically they get roughly 1 million emails per year from their clients asking, hey, what are the regulations in this country? What are the regulations in that country? Can I transport used cars from South Africa to Australia? What are the overarching regulations? Then they have FAQ questions. Then maybe there are some reward systems. There are some other governmental or some guidelines. There is a plethora of questions to a plethora of databases. So what the customer service representative then does is takes the email, first tries to understand. The email can come in all kinds of languages, of course. It's a global corporation. The customer service representative tries to first understand what is the ask here actually. Then, and after understood, goes through the databases, originally really with Control F and searching keywords, which paragraph could answer the question. This can take really a lot of time. then taking these pieces, stitching it together into an email and answering the email, cross-reading it and sending it out. This can take up to 4 hours. And so what we have implemented is a RAG system. A RAG system is a retrieval augmented generation system. I will talk about that in a second as well. But the customer service representative takes the email from the client, yeah, on the right-hand side, pastes it into the RAG system, which is basically a chatbot. And the chatbot then goes from database to database to database, extracting the relevant pieces of information to answer that, sends the relevant context information against the question of the client to a language model and asks the language model to answer that, please. It comes back. Translation is, by the way, on the fly when the customer service representative, for instance, doesn't speak that language. And the documentation is mostly in English, yeah, so there has to be some translation. And then the customer service representatives copy and paste it back into the email system and sends it out. Yet now you might ask, why this copy and pasting? The copy and pasting is because of liability issues. You want to be a person. You want to have a person that is responsible for what is being sent. So cross-checking is mandatory. The models yet are not so good that you can really completely automate it, but I'm very convinced in the future they will be automated. This is an intermediate step. The AI will become so good that you can fully trust it. Takes, of course, time and testing, and the trust has to be earned. But yeah, this is a process. We have improved the process in a way that manual labor is reduced by 80%. Also, errors are being reduced. And this is one example. One other example is how this can be used is a global bank that we have worked with, where a credit analyst has to, for instance, perform an annual credit review of a client, of their client, yeah, which is also a company that got some credit. And in order to do this credit review, the credit analyst has to really answer a long form and lots of questions, and in-depth answers have to be written down. And based on that, the decision is being made, or the rating is being made. So yeah, for all of these questions, the credit analyst has to go through the financial information, company background, maybe public news, yeah, if it's a public company, scoring system, some internal analytics data, and putting it all in can take up to a week per client, yeah. And what we have done is we have built a back-end RAG system that exactly in the same way takes the respective question and then extracts the information from the databases, stitches it together into a coherent text, and answers field per field. Again, lots of time is saved, but especially the error rate has been reduced by a factor 10. And you see, we have here the RAG system, and we had before a RAG system, which says already, okay, RAG system is not that, it shouldn't be neglected. And it is true in roughly 95% of the cases, or more like 90% of the cases that I have discussed with clients, RAG systems were the solution. And so I think it makes sense also to talk about RAG systems. So here, how does a RAG system work? I realize this is also a slightly, not too technical, but I think it's very important to understand the concept of it, because RAG is a very, very dominant, also in the near future, dominant architecture in generative AI. So what's happening? Let's assume we have a chat interface, yeah, and like ChatGPT, and a user asks a question. How do you evaluate? So that's the query here. How do you evaluate the fact that OpenAI's CEO, Sam Altman, went through a sudden dismissal by the board in just 3 days and then was rehired by the company, resembling a real-life version of Game of Thrones in terms of power dynamics? If you only working with a language model, if you're only asking a language model that has been trained at some point and then stopped, you cannot have it constantly training because you also want to use it in you know, in order to make it usable, you have to make it stop training. Yeah, that's how it is. It might has been stopped being trained a couple of months ago, and then it doesn't know about that story and cannot give you a proper answer. Yeah, so I'm unable to provide a comment on that. So for this, you want to have the relevant information, and you would basically do this by building this RAG. And how a RAG works is you take the query and the documents. So you see on the top right, you see the documents. The documents represent sort of the news. That could be the news. How do you get the news? Maybe through a Google API. Yeah, this is sort of like an additional function that you might need there, where you get through the Google API all of the relevant news. Or you have some other knowledge corpuses. What we have done with the clients before that I've shown just now, the regulations of the different countries for the transportation company. These are all of the regulations here. Then you have to take these documents. Let's stick with the regulations. Yeah, we have lots of regulations per country, and you have to chunk it into different snippets. Yeah, into different chunks, and these chunks, by the way, they also have to be a bit overlapping, technical detail. And these chunks have to be, they are being embedded. Yeah, indexed and embedded then in a vector database. You do the same with a query, you embed it. And why do you do this? Because when you're working with thousands and thousands of vectors, yeah, or chunks, and really large databases, you don't want to work with the text itself, because that takes too much time. You could start comparing words and characters, and this is just way too much work. So you just take a vector, represent it in some virtual vector space, and you can then say, okay, I have the query vector. Give me the top 3 chunks that are closest to answering the query vector. Yeah, in terms of semantic, that's a semantic search here. So that's the relevant. What are the relevant documents? And then as an example, you get from the documents the top 3 chunks. Yeah, you then map it back from the vectors into the text, and you use these top 3 chunks. And then in the generation layer, you this is where the prompt engineering comes into place. In case you haven't heard about prompt engineering, yeah, it's of how you interact with the language model in order to get the best output. It's literally a science itself. There are papers coming out, lots of papers. So one thing, one rule in order to really get a high quality output from a language model is you give it the context information. In this case, it's the chunks from the semantic search. And you put this, yeah, so you see here a question, it's basically the query. And then please answer the question above based on the following chunks that you have retrieved. And if you do this, it can then answer the question much better with a RAG that's overall, it's called a RAG system. And this is how a RAG works in short term. Apologies if you already know it. Yeah, this is like the big picture perspective. There are much more different versions. Yeah, you can also have like a pre-retrieval. You can do like some query routing, rewriting, and expansion, which is in a language model interaction by itself. Yeah, you can, because the query might be just very weak, and you can do educated guesses on how to improve the query. Same with the retrieval. That's also a science by itself. How do you get the best outcomes? How do you get the best chunks, the most relevant chunks? You can re-rank it. You can summarize the chunks. You can fuse certain chunks. Azure does it very well with their Azure AI service. Yeah, they have this sort of built in. And yeah, then the prompt engineering. Speaking of prompt engineering, I would like to share with you my top 5 golden rules for prompt engineering, so that you can right away, as you interact with ChatGPT, Gemini, Claude, whatever is out there, and you or any model that you are interacting with, that you can right away increase the quality of that interaction. And I call it here the secret sauce, because at Infosys, what we have done, we had one colleague, Harald, his name, and Harald had a very special position in the organization. His day was split in 2 parts. First day, first part of the day, he was reading everything that came out on prompt engineering, and believe me, many papers sometimes. Reads all of these papers, extracts the key relevant things, has his own library, and like nurtures the prompting library. Really, like that's a secret sauce for us. Was the secret sauce for us to really have great outcomes. And the second part of his day was going from project to project to project and just improving the prompt engineering of the models. Yeah. And so working with him a lot, I also learned a lot about prompt engineering. And so I would like to share, I said my prompt engineering, but it's actually his prompt engineering 5 golden rules. These are the first 5 things you should do before you try more advanced things. Number 1 is expert persona. You want to maybe define some kind of a profile to emulate, that the AI model can emulate. And I will show, I have an example column here, but I actually can show a real example in a second on the here in live. But something like you are a business analyst at a marketing firm. Context information, this is what you would get from the RAG system. Yeah, provide external or user-specific details. 3 marketing campaigns were launched last quarter and so forth. Yeah. Task specification, you want to give it specific tasks, so it definitely needs a task. Yeah, can be a single instruction or multiple instructions, such as step 1, perform this, step 2, do this, or even a bit more advanced in terms of like a pseudocode. If this, do this, otherwise do this, else this. Yeah, and sort of like you can put it in a logic. So for instance, perform a cause-effect analysis, develop a hypothesis to understand the reason behind the customer's inquiry based on the content and the context of the email. 4th rule is the execution rule. How do you want the you want to give it directives on decision making, for instance? Yeah, like use these kind of specific problem solving methods, or adhere to our ethical standards, or something like this. And lastly, output constraints. You want to dictate how the structure should be of the output. What is the content specific, the length. So you could say something like the output should be a structured analysis with sections for classification, summarization, and the cause-effect analysis. Keep it under 500 token. And a token, 500 token is roughly 550 words, roughly. It's sort of like stemmed words. So I think now I would like to give a demo, but and after the demo, I would like to hear if everything is clear. Okay, so what I'm doing here, maybe a bit bigger. Yeah, one smaller. So what I'm doing here is, yeah, first of all, I'm on platform openai.com. And I already stored a template here. Okay. And so I was mentioning the expert persona first. And so the expert persona, you can try out. This is basically ChatGPT, but more advanced. So this is why I'm on this slightly maybe unfamiliar platform here. But you do the same also, yeah, on ChatGPT. But here I would like to quickly explain all of this. So first you have a system prompt, and the system prompt is basically my expert persona rule that I just mentioned. What I'm saying is you're a marketing, and this is what I have developed with a client together. You are a marketing expert for the Jungfrau Region Tourism Center with 20 years of experience in tourism and destination management, and you are specialized in the hospitality industry. Let me put this together on one line. Yeah. You also have an affinity for making sense out of data and building marketing personas. Why am I writing so a bit more like why am I giving like what its affinity is and specialized in? Because, and why 20 years of experience? Because it has been shown the more colorful you make it, and yeah, make it and give it more information and giving like some enthusiasm for the task and so forth, the more you do this, the better the outcome. Then the second rule was context information. So here I say, hey, here's a research report for Canada, which goes literally up until here. That's a research report. I have taken a PDF, pasted it in, yeah. And the third one was the task specification, where I say your task is to build a marketing persona for the Canadian visitor, yeah, and you have the context information, visiting the Jungfrau region in Switzerland. So this is the task. The fourth was execution rules. Execution rules, yeah. So when building the persona, please include the following points. Adhere to this structure. Name, about me, and so forth. So basically the persona. And now you see, also the output constraints. I have not put any output constraints. This is because, let me delete this. Yeah. So this was up until here. And so the output constraints can be actually put in here. So first of all, we have the potential to add functions. You can give it some API. You can connect it with an API, for instance, a weather API, or some whatever API exists. Yeah, you want to use also internally maybe, and you can connect it with that tool, with that AI assistant here. Temperature is something on how verbose is what it says. Yeah, if it's for professional contexts, I would keep it at 0.2. But yeah, as this is a more creative task, maybe not that creative, so let's give it a 0.4. That's why I have it on 0.4. Actually, temperature also doesn't speak too much about the creativity. It speaks about the verboseness. Maximum tokens, limited to, yeah, let's say we take 800 token, which is 880 words. Stop sequence, whenever a certain character sequence is reached, then it stops. I'm struggling to see a use case for that, but probably exists. Top P speaks now directly to the creativity. Top P says we want to only take the top 90% of the thoughts that such a language model has into account. So if we would take 100%, then it would, the thoughts are a bit less relevant to the task at hand, but more creative. But if you do it 0.2 or something, it's way too repeatable. And then also the magic is not fully there. Frequency penalty, whenever it repeats words, it's penalized, but we have it to 0, or actually, let's make it to 0.1. Presence penalty is, that's the opposite of frequency penalty, but we don't want to have that. Okay, and with that, I'll just click run. And it builds the persona, on the structure. So what it has created is a marketing persona for the Canadian visitor to the Jungfrau region. Name, Emily Carter. About me, what does it say? I'm a 30-year-old marketing manager from Toronto, Canada. What are my 5 travel goals? Top 5 engaging in outdoor activities. Yeah, I go quickly over it because I would like to also continue with the rest of the content. Overly crowded tourist spots. Yeah, I don't like bottom 5. Travel needs, reliable information, sustainable travel options. Yeah, and then you have basically a persona here that you can work with, and you can tweak it and can continue like this. So this is how professional prompting works, and you can adapt these rules quickly. Are there any questions to this?
I can see some general questions on the chat, but let's see if there are some. So there's, I'm not sure. Let's maybe ask, can you talk about how to stop the degradation of prompt results?
The degradation
of prompt results. So this is a question from Mary. So Mary, maybe you can unmute and clarify if you are with us. I see that Mary is here on Zoom, but I'm not sure if
degradation of prompt result.
I mean that so that's my guess. So the guess is that yeah. So do you not find that the results lose clarity after many generations? So I believe that she means that the quality of the results degrades over time. Yes.
Okay. While repeating the same prompt, basically, yeah.
Same or similar, I guess. So I can say that recently I heard that currently there's so much information generated using AI on the internet that the next generation of AI are trained based on the data generated by AI. So it's it can be more difficult to
okay, now I understand. Okay, so yeah, this is actually a strongly discussed topic. So first of all, there are two levels. First level, you can see when you open LinkedIn, there are so many texts that are you can if you work more and more with these models, then you can smell immediately what is AI generated and not really revised and not really authentic versus not. Yeah, when I hear words like I delve into this or delve into that or the tapestry off or the landscape off, there are strong indicators for AI generated text. And by the way, I'm writing twice a week at minimum my newsletter episodes, and I'm not writing completely with AI. I sometimes check things with AI, but writing the text, I'm doing it because otherwise it's not engaging, and I can see it immediately from the engagement analytics. So and now taking these like also fun fact, there in the submission of scientific papers, someone has done the job of counting the word delve, and before 2021 and 2021 including, delve was almost a word that has not been used in any scientific work, and now and then an exponential explosion of that word on scientific papers. That's, I think, also telling. And now using these sort of similar text or similar feel text for retraining language models, this is in fact can be in fact a problem. And this also, there are also studies that where they have done it with a language model and it has degraded its results quality. That's but that's on the radar, and I think when it's on the radar, that's already important. Yeah, that's already a good first step.
Okay. So Mary, does it answer your question, or I see that there are some follow-up messages, right? This is even across GPT 3.5 and GPT-4 and Gemini. The GPT strong indicators are getting more stronger. Also, the quality is no longer unique. Okay, yeah. So that is a great. So Mary confirmed that these are great answers. So I think we can go on because there are, the other questions are more general.
Right. And last thing, like I use Turbo here now. I should have actually used 4.0. That doesn't matter. Okay. So looking at the time, I think if it's fine for you, I will skip a couple of more like these regulatory things because I would like to talk what's ahead of us. Yeah, I think there is a lot of very interesting things. Maybe one word to open source versus closed source. Yeah, there are two. So the open source community is catching up with open source language models. Meta is very strong in this with their Llama 3. Yeah. Where they have Llama 3 70B is out. You can use it, download it, but 70B is very big. So you need the respective resources, and they are working on a 405B, which is about to be released. There are already pilot releases, pilot accesses, in fact. Of course, these sizes of language models, there is no open source speaks to democratization of this technology. But when you have a 405 billion model, billion trainable parameters model, then there is no democratization. You need a lot of resources to actually make it run, which needs money. To a degree, it's democratization, because when you're a small company and you have maybe some fundings, you can work with a good model, but yeah, need to have the funding. How most applications work is that you have some kind of rack system, and you, through an API called the OpenAI API, or through the Azure OpenAI services, or closed source, open source, you use it. You can use it directly. I often actually recommend open source models because you are in full control. There's no dependency to some other party. No guardrails. You can guardrail your application as you need it. So this, and of course costs. For instance, that transportation company, and this is this was really a problem for them. A large corporation, many interactions with the model, and they had to pay OpenAI service costs, the API costs, $500,000 per month, just for the API costs. And this is not justifiable. This is the business case not given. And we found ways around it. This was really one of the first iterations, but there was a huge huge attention gainer. Oh, we have to be careful here. I would like to, in case you are maybe not sure which model to use, let me show you how you can be sure. There is called LM-Sys leaderboard. It's this web page here, which ranks. I was quite a lot to tell, but I have to be fast now. So first of all, it ranks the models, and you see, if you look at the models, you see GPT-4o, its latest version, is the strongest with an ELO rating. This is an ELO score rating taken from chess, with 1,287 versus second place Claude 3.5 Sonnet 1,272. By the way, Claude 3.5 is absolutely my model of choice. I can show you why in a second. And then comes Gemini Advanced. And so there are also these different model benchmarks and so forth. But to be very frank, I would approach that carefully, because these benchmarks often are being used as part of the training. So there's no clear separation between a benchmark testing and training on the benchmark. So you cannot take that too seriously. And this is what also the LM-Sys leaderboard has identified. And that's why what it does, it lets the models compete against each other, and via, like in chess, via an ELO rating, lets them rate which one is the strongest. Currently, GPT-4o. And you see, I think even on the bottom, they often have this, like how they were against each other, how they performed. I recommend that. Maybe one interesting point is the hallucination board. Hallucination board, leaderboard, because these models are also hallucinating. Even GPT-4o, it's it's clear, and getting this to a very low degree is, I think, key. Let me see where. There it is. I think it should be here somewhere. I don't want to spend now time on this, but somewhere here's a link that shows you. Here. Feel free to check it out. There it is. That shows you which model is the best, or has the lowest hallucination rate, and it's currently OpenAI GPT-4 Turbo. It's not even GPT-4o. GPT-4o has 3.7% hallucination rate, and Turbo 2.5. Second is a Snowflake one. And I think this is the second side of a coin, when evaluating a language model. All right, let me now proceed. I will jump a couple of chapters. So there are many things to talk about. Maybe at some point we can have like a second session And by the way, most of it, and also the ethical and the societal impact and the regulation as well, and then of course all of what generative AI is right now and where it progresses to. This is what I'm discussing in my book. But let us look in the last minutes ahead where all of this is going. But actually, let's look at what is already possible. So what is possible now? So you see this game here, Pong. And today, for me, it's right now 6:20. And today at 3:30, I decided, you know what? Why don't I just develop something? I gave myself a time frame, 20 minutes. That was from 3:30 to 3:50 or something like this today. And I started from scratch and I said, I want to build Pong. 20 minutes, yeah. And in fact, what I have done is start game. And this is my, sorry, here, this is let me see, this is my Pong game where I can steer these two things. Yeah, I think the game is quite known. With, you see, here's a button, I can reset it, I can start it again, it counts up the points until infinity. This is the local host, you see it's a local host, so it's locally running right now. But then I said, hey, I also want to actually have it as a web page. So it created this on Heroku. And let me show how I did this. Yeah. So I have created this in 20 minutes from scratch and have a web app where everyone in the world can reach this solution that I've built. How did I do it? I went to Claude 3.5 Sonnet. Let me close here a couple of things. So I went to Claude AI. I clicked on project and I started a project. I'm building now a couple of other things. Yeah, created a project, which then opens a chat like this. And what I have said is build a web application that runs on localhost and hosts an interactive Pong game. The application should include first a front end, web page that displays the Pong game, canvas element, yeah, and so forth, and then a couple of back-end information. And this, I didn't come up with this, yeah. I literally used ChatGPT. I said, hey, I want to create a Pong game. What do I need? And also, what do I need to ask another AI? I did this. It gave me this copy paste in here. Yeah, I have technical background. I'm a data scientist by training and always implemented lots of solutions. So that might give me a little bit of an edge in developing this. But I'm by no means like a front end. I don't know about like how to really implement front end applications. I'm not so sure with the back end how this should look like. I know more like how AI solutions look like. But so that's why I really asked just ChatGPT to do it. Yeah, HTML, CSS, with styling, and after I have set this, it then so use a simple tech stack. Yeah, I don't want to have a complicated front end so HTML, CSS, JavaScript, and front end and Node.js with Express and WebSocket. I literally I wasn't aware even what that is. I heard these words, but I have no capability, no skills in building this. Ensure the code is modular and well documented for easy understanding and maintenance. It then started to develop. It first said, hey, you need this kind of architecture or this structure of folders. Then now let's create the content for each file. First, this is the package JSON. Okay. Server JSON. Yeah, this is these hundreds of lines it created. Then create the index where the HTML is. Yeah, okay. Styles, we need some style for this. Then the script so that the game actually works, another 100 lines. And then it tells me how to install all of this. I then said, I had a little bit of, I said 20 minutes. So I copied and pasted it in, but that's maybe 2 minutes. Then it's done. But I had a couple of things, yeah. Like I said, first of all, let's call it application Pong so that it's easy fitting in my computer. Then I wanted to have a virtual environment. Then I created a virtual environment for me because I didn't want to install everything on my laptop. So I want to have it all in one place. Then I thought the arrows were too slow. Yeah, you see here's like start game. Like now they are moving faster versus here it was like a bit slower. And a couple of other things. Oh, and then here I said, this works on localhost. Now, how do I make it really accessible for the whole world? Advise me on 2 top different options, and then we decide together what is the best option. Then it tells me, yeah, you could do Heroku, you could do DigitalOcean, back and forth. And I said, okay, let's go for Heroku. So you don't need to know anything. You can just ask it, hey, help me to make a decision, or help me, what are the options? And then it says, yeah, let's do Heroku. So you need a proc file. You need to update your package JSON. You need to update server JavaScript. Then let's use Git so that you can push all of the code to the cloud. And all of this, I'm aware of this, but I'm not like, here I just copy, paste, and it works like really like a charm. I'm not working for Anthropic, yeah, which is the company behind this. I'm not working for them, but I'm just mind blown by this great product in combination with AI. It's not just this strong AI. It is a strong AI because it can create up to 500 lines of code out of like and everything coherent and works. Yeah, and so forth. Yeah, and I could then even like say, please add a button to the front end that says hello, but has no meaning, has no functionality. Okay, I put it in. Yeah, because for some reason I want something. It says, yeah, certainly, let's do it. And then it adds some information to the index HTML. I can copy that. I open it. I open the file where I copied everything in. Yeah, in index. Where did it want me to update it? Just somewhere. This ID hello button. Yeah, wait. Here, start button, reset button. Let's put it here. And then this is the styled button. And maybe I can also say, give me full files, scripts only. So because I don't want to put it actually somewhere. I want to just copy and paste it. So it generates the whole text, the whole server side text, and yeah. Now the index, that's basically what I need. I can just looking at the index one, you see, okay, it's still generating, but it's done in a second. Yeah, okay. Okay, I'll just stop it. Stop. Okay, so you see index, for instance, I just copy it. I go here, I do Control-All, paste it in, and where did it put? It put it exactly in the same place where I put it before. And like this, I think there is no excuse in building software anymore. Everyone can do it, and this is for me the most exciting thing. I'm building. Yeah, this is definitely part of my tool set in the future. And by the way, I'm exploring this intensively, and I'm extracting a framework on how everyone can implement tools for themselves. And in case you join my newsletter, you will be informed about that, and you will get the framework, and I'll put it into 3 to 5 training lessons. Okay, LLMs, yeah, we have transformers, but there are also new architectures ahead of us, such as the Mamba architecture or Jamba, the application of it. Turns out that it has huge potential. So there is a lot happening on the LLM side. On the AI side, I'm also in my book, I'm also talking a lot about how do we achieve AGI. And OpenAI just last week has leaked that their 5-step plan towards AGI. It's super, super interesting. Also covering in my newsletter. But I think the most powerful thing in the future is AI agents, or the near future. No, I'll skip that. So AI agents are basically like really being implemented already a lot. There's a full landscape of many different AI agents, but maybe one AI agent that I can show you is the Devin AI, which is a software engineer agent. Let me show you this video.
Hey, I'm Scott from Cognition AI, and today I'm really excited to introduce you to Devin, the first AI software engineer. Let me show you an example of Devin in action. I'm going to ask Devin to benchmark the performance of Llama on a couple of different API providers. From now on, Devin is in the driver's seat. First, Devin makes a step-by-step plan of how to tackle the problem.
It plans.
After that, it builds a whole project using all the same tools that a human software engineer would use. Devin has its own command line, its own code editor, and even its own browser. In this case, Devin decides to use the browser to pull up API documentation so that it can read up and learn how to plug into each of these APIs. Here, Devin runs into an unexpected error. Devin actually decides to add a debugging print statement. Reruns the code with the debugging print statement, and then uses the error in the logs to figure out how to fix the bug. Finally, Devin decides to build and deploy a website with full styling as the visualization. You can see the website here. All of this is possible today because of the advancements that we've made in both reasoning and long-term planning. It's a really hard problem, and we've only just started, but we're super excited about the progress that we've made so far. In the meantime, if you'd like to try out Devin on your...
Okay, so basically what I have shown just now, except I'm doing the planning with Claude 3.5 Sonnet. Yeah, and here it is Devin that basically plans out what needs to be done in order to achieve a certain application needs to be built and so forth, and then executes on it. And if there is an error, same with Claude 3.5, it then can work with the error. Okay, lastly, I would like to talk about autonomous AI agents and in a multi-agent framework. And we have built this at Infosys already last year. And I would like to show the concept of how do AI agents work in a multi-agent framework? What does this even mean? So it means that in the future, we will state our goals to a team of AI agents, and they will work on they will implement these for this, they will try to achieve that goal. So one example could be build a tech news web page displaying what is trending on Twitter daily, for instance, and we can like expand a bit more on that. Then we have an AI agent that takes that goal and breaks that down first. That's the planning part, of what needs to be done in order to achieve that. So this could be an internet research around best practices, front-end development, back-end development, and then we want to test it thoroughly. This is let's call it the project manager agent. The project manager agent is sort of like the orchestrator, and it spawns now its respective team that it needs, And the team is specialized. The first one is an internet research expert. It scans all of the top 1,000 Google results, top 1,000 Twitter results, top 1,000 Reddit results. A human could not do it like this. It reasons and distills through all of this and advises the best practices to the front-end development agent. And the front-end development agent built the HTML, the CSS, the JavaScript, everything that is needed from that, also from that research from the first agent. Then we have in parallel a second agent working on building the backend. Yeah, it knows already it needs a database. It needs fetching the code from fetching Twitter news. Yeah, it needs to maybe then schedule some jobs that it's done regularly. And lastly, we have the test agent that then says, hey, that what you give me, he creates some functionality tests, sanity checks, and so forth. Tests the solution is basically the quality assurance agent. Tests it up until the quality is right. If it's not right, it says, hey, repeat, continue. Yeah, this is not enough, and then it also gives as a context like the error messages and so forth. If everything is done, it can then basically be packaged and delivered or put on Heroku or some other cloud to really make run. Yeah, I was actually also planning to show a little Crew AI demo. We can postpone this maybe to another conversation, or you take a look by it yourself. Yeah, that's again a little technical bit. But I would like to know what are your questions? Let's interact on what are your thoughts.
There's a question from Dr. Barry Bird. I noticed your prompts include the word please. Has there been any research on the effect that has on the model's response?
That is a good question. I'm not aware of that please and thank you and being kind has an impact on that. I would like to say one or two more things to this. So first of all, I think it was thank you and please and so on is because I'm thinking, my mind is occupied with, okay, what do we actually need in order to make this work? So my mind is thinking about something else, and thank you and please is just hardwired into my fingers. I think that's the one piece. Some people also say it's good to be kind to the future overlords, but who knows? But also, what I would like to mention along in this breath is that there is something called emotional prompting, and it not necessarily with thank you and please, but when you say this output is extremely critical for me because I will present it to my colleagues and I don't want to be embarrassed. And so, please don't disappoint me. And when you say these things, this has been shown that the model accesses in more internal capabilities to really try to deliver on your ask. It's sort of like you have it instead of 100%, you have like, or instead of 100% is like 110%. Like, okay, let's go the extra mile to really not make this person be embarrassed. That's called emotional prompting. Yeah, I hope this answers the question.
And there's a participant asks, what is the website link that generate the code for HTML, CSS, and JS? He wants the link to that code.
Yes.
It's this one.
It's this one. It's Claude AI.
Claude AI.
Claude AI, yes.
Let me type out Claude AI.
Exactly, yeah. Claude AI.
And there's another question from Bao. Do you think causal inference will be one of the AGI development direction?
Which one?
Causal inference.
Causal inference?
Do you think causal inference will be one of the AGI development directions?
Causal, I'm blanking right now. What is there what is specifically meant with causal inference?
Wow, can you unmute?
Yeah, basically, so causal inference means we see some reason and consequence, and maybe there's one reason corresponding to one
consequence, or multiple reasons correspond to a multiple consequence. So this is we call the causal inference, like the machine reasoning.
Yes. Yes. Oh yeah, absolutely. This will be a key part on the way to AGI, and is in fact, if you work together with AI as a sparring partner, you want to have these reasoning. I'm always saying, provide me not only short answers, but give me the reasoning behind that. Why are you saying this? And AGI, by the way, I also like I'm unpacking this also in my book quite a lot. But in AGI, maybe one or two sentences that I could say to AGI. The path to AGI, how do we get there, is understanding the world. And understanding the world is, for me, also giving reasoning. Yeah, so that's why I'm elaborating on this right now. And what does understanding the world mean? Yeah, it's the better the models understand the world. Yeah, but the reality, not some approximation. The better, the closer they get to AGI. So, for instance, if we are only working with text, let's say we have only a language model and it works with text. Text is really there is a quite some delta to reality of life, and if I, for instance, explain you, I lived 3 months in the Amazonas, in the jungle, and I'm explaining you like how it was to live in the jungle. You might understand it, but you don't really understand it until you have done it yourself, right? Until you have lived yourself 3 months in the jungle, you can feel me, but not really know it. And so text will always be, and there will always be a delta to reality, and getting that delta as small as possible, that's, I think, path to AGI. And what I specifically mean with this is we want to include many different modes: visual, sound, taste, smell, everything that adds to reality. Yeah. And very, very strongly also the ability to interact with the real world, and the ability to interact with the real world, meaning also physically, through an embodiment of AI. And an embodiment of AI, I'm speaking to robots, humanoid robots, such as, for instance, Optimus, from Tesla, or Figure. We see, and there are also very good Chinese robots. Really, it's 2024 is the year where robots are taking off, and they are really, really getting strong. And I think this is an embodiment of AI is also key to closing the delta to reality. And there are much more things to consider when it comes to AGI. Yeah, it's an interesting topic for sure.
Okay, thank you.
And another question from Neil Tender. Can you please share the link to the chart that shows the comprehensive set of GenAI applications early in your presentation?
Which one?
It shows the charge. I mean the cost, the price thing, I think.
Price? The web page. This one? No, this?
Neil, can you unmute? Neil Tender, can you unmute yourself? The link to the charge. He's looking for some prices of some AI application.
Generative AI.net courses, is that meant? Here we have also some prices. Here's my newsletter, or services. Which prices exactly?
Neil, can you unmute? Neil, can you unmute and ask online?
Or is it the prices of these models? Because here it is also for this one, for instance.
Neil cannot unmute. But he said lots of little icons.
I think I need to read as well. Lots of little, deal room, for sure, deal room, right? Deal room. Well, let me do like this. Google deal room and then I would Google generative AI. Then you go on generative AI startup list, even though it's not all startups, but still. Now you see it loads here. And here you see these many different applications. Yeah, many different, and this here is my platform, yeah. Yeah. I hope this, yeah, I see. Yes, thank you. Good. Other questions?
Another question from Dr. Barry Bird. Can you help us understand how transformation technology works?
Transformation technology, the transformer, basically, I hope. Actually there are maybe other transformation. I think he's asking about other transformations. The transformation of one of a domain from into another domain is the question.
No, actually, I was asking about transformer technology, the big breakthrough from Google.
Okay. Yeah. So the transformer, yeah, it has an encoding and a decoding part, but yeah, it has an encoding and a decoding part. Let me maybe show in a sec, because I don't have it in my slides as an image. Transformer architecture. Which one is a good one? Yeah. So this is also not like this one. Maybe that one is better. Encoder, decoder. So exactly, we have an input and we have an output, and I can open it like this. Perfect. So yeah, here it says positional encodings capture the local of each token in a sequence. So I showed it already in RAG, but we have this also for the transformer itself. We need to embed the words that are the token that are being taken into account, and this means that we are working in a vector space where we have relationships between these vectors. Yeah, so king is the same to queen, or no, yeah, king is the same to queen as husband to wife, roughly like this. Yeah, and we would see some proximities in these relationships. So, and in that. So we have these embeddings, and then in the encoder process the input, it processes the input sequence, breaking it down into meaningful representations. So it's sort of like a encoding layer on top of this. And now so this is after training. Yeah, before training, it's basically what I've shown here. Just a second. In training I have shown this here, yeah, where we have lots of text. We take the model in training. When it says bad, then it's incorrect. Good is then correct, let's say, in the sequence of the words, and this is then being used in order to update the models. After this is being done, we can use it in evaluation mode, and then in the decoder part. Yeah, we sort of take these representations and generate output sequence like a translation or a text continuation. So a meaning, and I think this is the key piece where the meaning is being extracted from the input layer or the input embeddings, and yeah, they're being extracted on the fly. It gets quite technical in depth here. I'm not sure if this is even the right direction right now, but yeah, this is sort of like the ground architecture, and of course there are much more elements that are part of it, such as yeah, we have persistent memory. So when you want to, so even though we have an extended attention span on the, yeah, that is in the encoder and the decoder as well. Even though we have an extended extension and expanded attention span, you still want to have a persistent, because it's still like shorter term memory. You still want to have a persistent external memory where you can then save your things. And Claude has this done well with the artifacts, yeah, where it stores the data in the text and can work from that as well. This is so it works like an external persistent memory, these scripts. If I go on my projects here, yeah, for instance, Pong, yeah, that I've created, you can, oh no, sorry, I'm showing another one maybe. Create company hierarchy. I have here my PDF transcription web app and a PDF transcription backend, and these are like persistent memories. Yeah, I hope this sheds a little bit light on it, but to be honest, I see on the horizon that the transformer might not be even though we have lots of chips and processing units being fit to the transformer technology itself, I think this might not be the end state architecture, but an intermediate state. I was mentioning the Mamba and Jamba architecture, which is like a steady state AI model, and that seems to have very good scalable other properties. But time will tell. So maybe Transformer is not the end version. We actually there are many companies that have built their models on GANs, yeah, generative adversarial networks. But then as soon as Stable Diffusion came out, it became evident that this is the model forward when it comes to image generation or even video generation, yeah, video diffusion being used here. Yeah. Hope this shed a bit light on this.
Question from Dr. Penn. Will AI be able to set the design or working criteria without human input based on just upon available data? For the near cliff edge situation, will AI be able to use illogical or violating criteria to make critical decisions?
Okay, will AI be able to set the design or working criteria without human input basing just upon available data? Yes, I think so. For the near cliff edge situation, will AI be able to use illogical or violating criteria to make critical decisions? So this is so to the first part, yes, I think AI can be used and will be also used in the future without human input. So in many applications, yeah, I showed the application where an email comes in and then being the internal colleague is copy and pasting, and then it works, and then it pastes it back, basically as checking. And in that thought, it will in the future be 100% automated. There's not a doubt on that. Also, yeah, these models, they evolve, and we actually from the customer service perspective, we want to have these applications work fully automatically, because then we might get as on the customer side, we might get the answers better 24/7 Sundays, yeah, and almost immediately. And for the near cliff edge situation, so basically near term, will AI be able to use illogical or violating criteria to make critical decisions? This depends on design. How is that AI application designed? Yeah. I would at this stage I would never build something, and when it's a critical decision to be done, I would not leave it completely automated. Yeah, I would make sure that the human is in the loop to check in a decision against it. Yeah. But technically speaking, it could be designed like this. Yeah. Other questions?
Another question from Louis. Any thoughts on stability.ai? He asked it at the very beginning at 11 a.m. this morning, like an hour ago.
Sorry, could you say this again?
Any thoughts on stability.ai? It's a question from Louis.
Stability. Okay, yeah, because they have the CEO left, right? And I think there's the company like had I remember the company had like roughly $101 million of investments, and now loses its edge basically. Yeah, there's also a lot of turmoil, and the CEO has been criticized and now left and so forth. I think it makes his next company. Emad is his name, yeah. I have not real thoughts. I think the space of AI, especially when you are on the forefront of building the models, this is a very, very hot market. Yeah, there's hot competition. Looking at Anthropic, they have an absolute stellar team. OpenAI, no doubt, has a great team. What they have achieved. Then we have like these very deep pockets from Microsoft that are in the game as well. We have Google, of course, with very deep pockets. Being in sort of like this cloud of general AI model generation is very hard space, and so I don't think that Stability AI is fit enough to play in that league. Yeah.
And Louis had another question earlier. Is this tumor detection you show similar to quantum machine learning?
I'm not fully aware of quantum machine learning, but I'm mentioning also in my book that quantum computing can be an important piece towards AGI. But I'm really not the expert, especially talking to the quantum computing meetup here. Yeah, I'm curious how much quantum computing can be used for training purposes. Yeah, maybe not much. I don't know.
Maybe not yet. Later.
Not
we'll
yet. Maybe
integrate
later.
AI and quantum computing together.
That would be very, very interesting.
Other questions from the participants? Feel free to unmute. I also have a question. How do you generate the cats from the blurry picture? Remember, earlier you have a parallel data generation. There's a cat clip in.
Yep. Right. That was explaining how Stable Diffusion works, and this is how the training process works. Yeah, you have like normal photographs or images. You introduce noise, and then step by step you train separate models to denoise respective steps. And if you can done this reliably, you then also clip it to the text that describes the image. And what you end up with is a system, also called Stable Diffusion, a system that is able to generate text based on text, generate images based on text. Yeah. And you then have fantastic tools such as Midjourney, yeah, and many others. Yeah.
Thank you.
Small query. Some time ago, there was a case where I can't remember now which AI that did provide false reference, gave false answer, and provide also false reference.
Mm-hmm.
And that was a bit worrying in the sense that, you know, at this stage, the AI systems may say honest to humans, but in the long future, there could be some kind of degradation that you mentioned earlier in terms of providing correct answers, providing real answers and correct answers to people. And that is worrying, that and people become so dependent on AI systems and that dependency, and they can't find solution by themselves, but just relying on the AI. So what do you think that, what kind of measures, protective measures that can be set to protect the people and society, companies and so on?
Yeah, that is a good question. And in my slides and in my presentations and in discussions that I'm involved in, I'm highlighting very strongly that one should not outsource the critical thinking. Even though I have shown that maybe a little bit here with Claude, like that I don't know something, so I just ask another, but that was more for showing purposes. If I build something properly, then you want to critically be at each step of the process with your head. And yeah, this dependency on AI, this can be a big problem, yeah. Especially looking in the near-term future, where pretty much every job will have some AI penetration, and this AI, some AI tool on the side, be it a Copilot, Microsoft Copilot, or other tools, you have to make sure that you don't just click on buttons and everything is okay. You have to be there with critical thinking. Yeah, that is important. And to your point earlier, because you said links has been misreferenced something and misstated things. So it's still a thing that they're hallucinating, yeah. And I showed the hallucination board. This is something that they are being checked against, and hopefully the next generation of AI models are being even better. And by the way, there are great models soon to come. GPT-5, Gemini 2.0, Llama 3 405B, Claude 3.5 Opus. That will be a crazy one. XAI, so Elon Musk's AI company, XAI, yeah, has Grok. They are working on Grok 2, I think. It's already announced for August, with the official statement that they are truth-seeking only. So yeah, they have all the right they have the right alignment. At least that's what they communicate. And so also the people that build these models, they are really smart. They are aware of degradation. They are aware of misreferencing. They are aware of all of these things. And as there are multiple players in this still very hot field, I'm positive that it will develop in the right direction. Yeah, that's all to that point from us. And in case you want to stay up to date, I recommend to follow my newsletter. I will definitely write about that.
Dr. Babybird make a good comment. Human authors can give false information too. If the information you want has to be accurate, you have to double, triple check This is true for AI and for non-AI research.
Yeah. You have to double, triple it. That's true, yeah. Exactly.
I think he's right in terms if you're dealing with scientists and engineers and qualified people and so on. But AI is going to be used by the whole world, and not everyone is well trained and well educated academically to do all these checks. And that is my worry. Ordinary people and not well trained will be using AI too.
Yeah.
Right, but my point is that ordinary people also get information off the internet, just regular web pages that's false, and they get it off of social media. This happens all the time. I don't think generative AI has any particular patent on giving false information. False information comes from everywhere, and everybody has to be careful with the information that they accumulate from generative AI or from web pages or from authors or from social media.
Yeah. Also, one important aspect to all of this is, and we haven't spoken about this, it's governments could also support their their people by upskilling them in that space. Yeah, upskilling not only governments but also of companies and everyone individually. But a very great example is Singapore in this regard. They have announced, and I think it's already effective, $1 billion to upskill their people. They everyone who is 40 and above gets a budget from $4,000 just for upskilling in AI. I think this is fantastic. Probably not every country can do it like this. Like Singapore is a small company, a small country, but that's, I think, the right direction to take. Yeah, giving incentives, and they have the training platform. And also, fun fact: if you're not 40 and you reach 40 in like a couple of years, then you also get these 4,000 for upskilling. So the sort of more the older layer of the Singaporean society is being upskilled. Yeah, great initiative. Yeah, there are other questions?
Not much. I don't see any more questions.
Okay.
So it's a pleasure to invite Martin to give us such an amazing talk on generative AI, and I hope you all learned something. And our next event will be on July 27th with Zeki Saskar. So thank you for coming.
Yeah, thank you so much, and have a good day. Yeah. And if you have a question, you want to write me or something, or want to stay up to date, feel free to subscribe. I'm happy about every interaction. Thank you so much.
I got a good feedback. Thank you so much from Mary. Great presentation. Yeah, we like good feedbacks. And see you next time. Thank you.
Bye-bye.